everybody. In this episode of FUM0139 Machining we are going to create a gear rack. I'm going to use this material. This is some Eastern world, not that Eastern, it's not from China, it's from DDR or Russia. This is tool steel actually, and this is what I'm going to use to create the gear rack. It will be module 1 gear rack, and this is going to be on the quill, to drive the quill in this tailstock. I have created this picture. Let's see if I can put it so I can take a picture from that. This is just a picture this is 100 times of the actual size, and it will be I used it to see whether I can do this without these things. These are involute gear cutters. I have this is module 1 and I have 8 of those. And one of those could be used for gear racks, but this one is not very usable because it's so small diameter. I cannot make a 20 centimeter long rack, that is 8 inches about. So for that reason I will doing this the other way. I will be using slitting saw, slitting saw. Okay, so this is the vise, this is a small parallel. Okay, this parallel just goes under here. I checked that there is, I have already cleaned everything here quite decently, and now when I put this here and I try to tighten it, I can clearly feel how it rotates when I tighten it. So like that, you probably can see it. So we just choose one edge, which is, this is quite near, and then we put this this is copper wire. I put it behind here. So when I now get it straight, I will put it back on the back side here, on the moving jaw, like that. And then I will just even so gently tap it to get it level this way. Hopefully it becomes level. I'm not very convinced, but on the, let's see how it goes. But once we get two oh yeah, well, it just might be there. I will measure this distance and this distance. I can see clearly if it is too much tilted, but I doubt that. Well, I measured it this way here. Just this is a very coarse measurement. This is 41.9 millimeters, and from this end, when I measure it, it's 42. So 0.1 millimeter deviation between the ends, that's okay, because I'm going to wipe off the out of rectangular shape is more than that. So I probably need to take more than 0.1 millimeter. I can see when it's all the way through. started to cut the teeth a little bit. So this is 1 millimeter wide slitting saw, and the depth of cut is 2 millimeters, and distance between each teeth is 3.14, actually pi. So I make this list of in my Excel, so I know where to set my next tooth. Anyway. The second pass. I already did the other face of the teeth, now it's the other one, and it's the setup is the same. Well, I noticed that when I add this kind of machinist voice here, it dampens the vibrations and doesn't chatter so much. clearance in the bottom of the teeth. There is now a small pyramid which I now mill off. This one is a success. It works great. I tried it with module 1 gear. It meshes nicely, and furthermore it's the dimensions, these sides, because this is going to be in the quill, so it travels forth and back in there, and this is also acting as the key which is preventing the quill from rotating. So therefore this dimension, this width, should be very accurate, so that it's the absolute value is not critical, but it should be the same all over the place. Well, it is. Actually, I couldn't measure it. It's inside, I can tell this is inside 1/100th of a millimeter. That's the accuracy I can get with my instruments, so that I can trust the measurement. So I couldn't get any difference nowhere here, so it's okay. Another accurate dimension is the height of this, and that's the same. It was okay. Okay, so in the next episode of Finno machining we are going to do the hard, heavy metal. Till then, bye!